So your hypothesis testing is what we're going into right now. And hypothesis, you get two hypotheses. You get an HO, which we call a null hypothesis, and you get an HA, which we call an alternate hypothesis. Most kids will say HO, HA, which is fine, as long as you can differentiate between the two. And we'll figure out which one has an equal sign and which one doesn't have an equal sign. That's all there too. So a hypothesis test itself is a process, and I put this on your notes, is a process that uses the stuff that you collected from your sample to test a claim about a population parameter. So parameter meaning, if I'm looking at a sample mean, I'm testing a population mean. If I'm looking at a sample proportion, I'm testing a population proportion. If I'm looking at a sample standard deviation, I'm testing a population standard deviation. And the way the book sets this up is 7.1 will do the means, 7.2 will do the means, 7.3 will do the proportions, 7.4 will do the variance and the standard deviation. It's kind of set up for each one, but the setups are very similar. You're always making the inference about your population, because when somebody makes a statement like my tires will last more than 40,000 miles, and he's saying all his tires, it's impossible for me to go to every person that bought his tires and ask them if they actually drove more than 40,000 miles. So we take a sample and we base our information based on your sample. So again, whenever we do sampling, we follow the strictest sampling rules. They have to be done randomly. They could be stratified. They could be clustered. They just can't be convenience. There's no bias in these. So they give you a little example to read. I didn't give you this example. I thought we would just read this together. So here's a good, for instance. This is what we're going to be doing with this. For instance, consider a manufacturer that advertises its new hybrid car has a mean gas mileage of 50 miles per gallon. He's saying his mean gas mileage is 50 miles per gallon. That's a lot, isn't it? Even though it's a hybrid. So you suspect that it really is not 50 miles per gallon. So how could you show that this is false? You cannot test all hybrid cars, but you can take a random sample. Here's your sample coming up from the hybrid population, and you could measure the miles of each one in your sample, and you can come up with your sample mean. If your sample mean differs enough, and we run this through a series of tests, we're going to test this by doing other things. If it varies enough, you can decide that the advertisement is wrong. But you cannot say that the advertisement is wrong. You're going to either reject it or you're going to support it, or you're not going to support it. So, to test your population, say you took a random sampling of 30, and you find that the sample mean, you found a sample mean of 47 miles per gallon, and you look at your sample standard deviation of 5.5. Hang in there, guys. Does this mean the advertisement is false? To decide, you do the unusual. You assume that the advertisement is correct. You set the population mean to 50, you test the sample against the population values, and you make a conclusion. You conclude that the advertisement is probably false, or maybe your sample wasn't so good. You sampled 50, even though you did them randomly. Remember, there's always a sampling error. There's a possibility of a sampling error. So maybe you want to run this again before you make any statements. Your sample standard deviation, again, is we're taking the standard deviation divided by the square root of n. Okay? So we're taking that when we use these. And we're taking a look at these. The sample mean of 47 is now 3 standard deviations away from the mean. And that's unusual, isn't it? We have a different way that we test, but they're showing you how the test would come out. They figured their standard deviation is about 1 because they use their central limit theorem. So a 47 would mean that you're 3 standard deviations away from the mean. You really shouldn't be that low. That's unusual. So you can conclude that the advertisement was probably not correct, but we don't say not correct. We have a way of saying certain things. Okay. So that's where we're going with this. But of course, we have different things to do. And if you kind of remember your calculator, when we looked at your test, see the things that say test? These are the steps we'll use this time. Remember we bypassed everything and went to interval? These are the things we'll use. We'll set up a z-test. We'll put the mean in, the standard deviation, our sample mean, our end. We'll figure out which way our tails go, and we'll calculate your certain values that we'll test against. We have formulas for this, and we have calculator steps for this. So it's really not that bad. The one thing to get down pat is that you always get a pair of hypotheses. You get a null, and you get an alternative one, an alternate one. One represents the claim, and one represents its complement, what is not the claim. If I say that my tires go more than 40,000 miles, we're going to see that this goes like this. The opposite of this is less than or equal to. So 1 is going to be a null, and we're going to find that the one with the equal sign is the null. The one without the equal sign is the alternate. And I put that in your notes too. I kind of highlighted the null and the alternate hypothesis in the middle here of your first page. This is important. Your null hypothesis will always have an equal sign. Your HA, your alternate, has no equal sign. But put a little statement right here. Put a little statement right by your HA. This one does the graph. This one's how we sketch it. This one makes our sketch, our graph. And I know this is boring, it's a lot of definitions, but you just got to get the basics down. It doesn't really start to come together until we start to do this. Now, I also gave you this chart. I know you're math students, you can figure it out, but sometimes it gets a little tricky with the greater than, the more than, the less than, the at least, at most. You always have a pair. This is really important. This is the whole thing right here. You always have a pair of statements. The HO always has the equal sign in it. The HA is exactly the opposite. So if I say my population mean is, say, less than or equal to 10, my everything else but that, if this was your number line, 10, you got to get all of this over here, right? You can't close it again, so you open it and go like this. So my alternate, my opposite of this, would be that my mean would be greater than 10. Think of a number line, if you will. You've got to get a pair of statements. If my mean is greater than or equal to 10, here's my 10. I want the opposite. I want all this guy. I want my mean is less than 10 to be my alternate. Now the equal sign is pretty simple. If my mean is equal to 10, sorry, I'm just at 10 right here. So my alternate is everything else but 10. It is not equal to 10. That's how we do the equal sign one. Just so that you get used to seeing the pairs. And I gave you the statement where they go through which is greater than or equal to, which is less than or equal to. The ones that are confusing, as usual, and you guys understand this because you've done these before, are probably the at least and the at most. Here's the at least. Here's the at most. Remember, when it's the most, you're less than or equal to. When it's at least, you're greater than or equal to. The rest kind of like speaks for itself. But those are always the two that give you a little grief. So I wrote it in your packet so that you have that as a reference. So let's see if we could set up an HO and an HA. Remember, write this down somewhere. This is our sample. This is our population. You need to get your symbols correct. Your mean is X bar for sample, U for population. Your proportion is P hat for sample, P for population. Your standard deviation is S for sample, sigma, little sigma, for population. And your variance is S squared for sample and sigma squared for population. We have to use the right parameters in here. So a school publicizes that the proportion of its students, it's saying a proportion of all its students at the school, this is a population proportion, who are involved in at least one extracurricular activity is 61%. How do I write that math statement? This is my claim. This is what we're claiming. I'm the school. I say the proportion of all my students who are involved in at least one extracurricular activity is 61%. So I'm a proportion. How do I write the math statement? Which is mean. You guys hate word problems too? Is equals 61%. How do I make that into a decimal? 0.61. That's my claim. So start like this. This is my claim. Now, my HO says it's the one with the equal sign. So this is the guy with the equal sign. What's the opposite of being equal? Not equal. That's my alternate. Not equal. It's as simple as that. Maybe you want to write down an example to do. I didn't write down an example for you. Maybe you want to just fill it in on your page so you know how to do this. Okay. A car dealership announces that the mean time for an oil change for all of their oil change, so mean from the population, is less than 15 minutes. Oops. Less than 15 minutes. So here's my claim. I'm the guy that's the car dealership. I claim the mean time is less than 15 minutes. Does this have an equal sign or no? No. This goes in my HA. This time I'm using mean. I'm using the mu, the little u. What's the opposite of less than? Greater than or equal to. That's my alternative one. This is really like the whole basis. You've got to get these right, because later on we'll draw a curve that looks like this. We'll find the 15. We'll follow this symbol. We'll shade that in. So we need to know the HA is going to give us the sketch for the tail. And the claim is going to be either one. We said we can be either one for a claim. Okay, let's try another one. A company advertises that the mean life of its furnaces, all its furnaces, population, is more than, greater than, 18 years. Here's my claim. How do I write that? U greater than 18. Good. Is that an HO or an HA?
HO.
HA, because there's no equal sign.
So your claim is HO.
The HO always has an equal sign. Your claim could be either one.
So the other one's less than or equal
So
to.
the other one is less than or equal to 18. Now, eventually, this is what we're heading towards eventually. See this little chart that you did at the bottom of the second page? Now, follow the chart for me for a minute. My claim is my HA. So you're going to follow the top. Your claim is your HA. We're going to test this thing. So we always test the HO. If we reject that statement and we follow your claim as your HO, we will have enough evidence to support your claim, which makes sense, right? If it's not this guy, then this guy must be working for me. It actually will make sense. If I test this and I find out, whoops, I can't reject this. I kind of like this statement better. If I take this guy, I certainly can't take this guy, right? And then I'm going to have to not support your claim. So this is all going to tie together eventually. Unfortunately, it's piece by piece. So now you guys try it one. I think there's 3 of them there. If I can fit all 3. These are important. Whoa.
Whoa. Let me take out my glasses.
Okay. Work on these. You didn't do it yet. Okay.
Yeah.
So for the first one, what's the claim? John, give me the claim.
The claim,
Yeah.
M.
Uh,
M is
uh, not M.
It's the mean.
You.
Yeah, the mean is less than 74.
Nope. David, how about your brother?
I thought I could use less than 7.
What does this say? What is this word? These words. Is not.
Equal.
So if it is, it's equal. If it is not, it is not equal.
It's not a sample because it's a certain type of automobile.
These are populations. It's a certain type of their automobile, all for that certain type. Yeah, that's confusing that way. You're right. So which one is this? The HO or the HA? What's the HO, Will? Good. U is equal to 74. Good. The second one. An electronic manufacturer publishes the variance of the life of its home theater system is less than or equal to 2.7. How do we write variance for population? Sigma squared. So, how do I make that statement? What's the claim look like?
Sigma squared less than or equal to 2.7.
Good. HO or HA? HO because it has the equal sign. Good. And what's the HA? Greater than 2.7. Very good. A realtor publishes that the proportion of its homeowners who feel their house is too small for their family is more than 24%. How do I say proportion? P is more than, greater than 0.24. This is your claim. HO or HA? HA. Good. And the HO would be P is less than or equal to 0.24. Good. Okay. Couple more things. Turn to page. Come on, don't give up on me yet. Turn to page 359. 359. Okay, so for number 11, if my claim is U is less than or equal to 645, is that my HO or my HA? HO. What's my HA? Good. Okay, for number 12, if my mean is less than 128, whoops. HO or HA? What's my HL? Greater than or equal to. Good. Okay, how about number 16? My proportion is equal to 0.21. HO, the equal sign. What's HA? Not equal to. Okay, we're feeling that. Good. Now, look at number 17. Which graph matches up with number 17? A, B, C, or D? C, why? It's greater than 3 and the circle is open, right? Good. Okay? Now, the node for greater than 3 would be what? Less than or equal to 3. Very good. Which graph matches up with 18? D, because it's less than 3. How about 19? A. How about, not A? B. Why B? It can't equal 3, so 3 is open. That's a weird way to say that, but when it's not equal to 3, you need to have 3 open and then everything else filled in. God bless you. And the last one is A. Okay, we're kind of feeling these? All right. Feeling them. Okay. We'll call it a break.